All right. While observability is a trending term in the industry these days, but it's important not to be misled by it. It's important to get a visibility into the system's metrics and from the applications and services, but that provides only a limited understanding of the overall performance of the system. To get a comprehensive and comprehension of the observability metrics data, it is important to employ the contextual intelligence and conversational capabilities. Now, my name is Vishwajit Paul. I'm a senior lead, and with me, Mani Nagaraj, senior data scientist. We are from JPMorgan Chase, and we are part of engineers platform and integrated experience, primarily focused on observability of every stage of the SDLC. Our goal is to help engineers detect issues early and proactively and automate troubleshooting and provide them recommendation to help solve their day-to-day life. Let's talk about observability. We know that 3 pillars of observability: metrics, traces, and logs. Metrics tells us that there is a problem, whereas traces takes you to the problem space where the problem exists. And logs tells you what exactly going on, what the problem is. So in observability, what we do is we collect, correlate, aggregate, and analyze the telemetry in your network, infrastructure, and applications. And these insights help you detect, investigate, and remediate problems faster. AI and ML can help proactively react, predict, and prevent problems, and allows analysts to explain the unexpected and address the underlying causes more quickly and more accurately. So a typical day of a data analyst looks something like this. They have been asked tons of questions ranging from everything, and not only from just one domain. There are different domains where the questions are being asked, and we keep answering the questions one after the other. It never stops, basically. It starts with something very small, but then it transforms, and there is a back and forth that happens, and you exchange data, exchange numbers, and that goes on and on. So we have been collecting this data from the platform in terms of the metrics, logs, and traces probably over like a couple of years now, and we have tons of data everywhere. So we are able to answer these questions. The problem is it takes a lot of time and back and forth. So what do? So we got together in a room one day and started discussing about the problems, what we have in hand. Apart from the questions which we have, a huge number of questions which we had. So what we saw is there are multiple personas, people coming in for asking the questions: developers, project managers, PMs, CIOs, customer success, and many more. And they have their own areas of interest. Some wanted platform and performance, some interested in application stability, some wanted insights from the CI/CD, some wanted recommendations, some just wanted pure raw data from their logs or metrics and traces, and they just wanted to do on their own. We had everything. We have dashboards for each and everything. It just spread all over the places. And at times, we just had to create some dashboards quickly with the data they are looking for. So, and eventually what we have to do is to increase the market value by saving the time and also reduce the cost. So we came up with this idea to create a virtual assistant kind of thing where you ask the questions in simple English terms, given an interface. And the system understands what you have asked and transforms the question into something which the machine understands, and then pass on that message to the query service, which it understands where to get the data from and how to present it back. And we present the answers back the way the user wants to see the data. Not only just the textual format, but sometimes just numbers, sometimes graphical representation, and at times just the pure raw data which can be downloaded. So there we have a system which looks like a human being answering the questions and responding back. So I'm going to hand over to Mani, who is going to talk about how we started building this and what are the different components, which all models which we have used, and also how the reinforcement learning took into picture to provide more accurate results over a period of time.
As we all have heard so many AI-related talks the past 2 days, even within JPMC, we thought it's the right moment to jump onto the bandwagon of using LLMs. So to build a contextual learning system, it involves deep understanding of the domain and also the data behind it, selecting the right models, which at the end of the day provides relevant and personalized experiences. So like I said, it's a combination of domain expertise, pre-processing of the data, the right model, training, and also continuous improvement. It's an iterative process. It does involve looping in the feedbacks that we get from user experiences, and also as and when there are more evolving contexts. So we built a self-service application which tackles natural language queries free form of text. And it can come from any different persona, like Bishwa mentioned. And under the hood, we are able to translate this natural language query, break it down the semantics like entity, the intent, and also the metrics that a user wants to see, and provide the relevant experiences and also additional statistics that the user wants to see. So just going over some of the NLP components, I hope you guys can take some of the tactical tidbits here to have conversations with your data scientists if you are building some similar applications within your company. So any text starts with processing because machine learning involves numbers. So the first step is transformation of this text into numbers. So the starting point is removing and cleaning the data as such the machine can understand. So it involves removing punctuations, special symbols, numbers which come into the text, and then basically removing the stopwords which doesn't add any significant meaning to the data, like and, is, war, for, what. And then breaking these text queries into chunks, which can then be fed into the machine learning models. And then choosing the right models. I'll go over in the next slide. What are the different LLM models that we use for this application? And then also have to have a design system that interacts with the users where it can take in these user queries and then outputs the data or the relevant visualization that the user is requesting. So we use Streamlit to integrate our trained LLM models as an interface which can accept free-flowing text and then also outputs the relevant statistics. I find one of this pre-processing step of very interest where we tag a query, a natural language query with parts of speech tagging. Why is it interesting? Because when we break down a sentence into its parts of speech, like assigning grammatical labels to them, it gives the intent the user is looking for. So it helps us understand the context and also transform this natural language query into a user query, which we can send it back to our database engine to get the appropriate response back. So we know when a user asks a verb like show, they are asking for some kind of visualizations. And if they are asking for a trend, a chart, or a drift, or a rate within the query, that means to say they want to know some kind of comparison. So this helps us send the appropriate query back to our data warehouse to get the appropriate metrics back. Just going over some of the large language models that we have developed for this, tweaked a little bit for this purposes, is one is a custom entity linking model, because within JPMC we have very niche business units and also organizational IDs, which come from our own knowledge database. So we couldn't use any of the out-of-the-box models. So we retrained some of these models to customize for JPMC. And to understand the intent behind a query, we used zero-shot model, which is from Facebook. It's a out-of-the-box model. It had worked very well for our purpose here. We are in the process of making some tweaks, but at the end of the day, it identifies the intent behind the user query, like what, where, when, and how. And these are mapped to our database queries so we can retrieve the information faster. And also, to give more enhanced user experience and keep the conversation going, we thought having some suggestions of the questions that would help users to interact with the system more. We use sentence transformer, which uses similarity pairs between questions. And so when a user comes with a question, it automatically recommends, hey, do you want to know more about these? So based on other developers' queries, so there's the conversation going on between the application and the user. So just to add on to the questions based on similarities, say, for example, a user or developer comes and asks, how many pipelines did I trigger last week? The system will recommend, hey, do you want to know how many pipelines did you deploy in prod and dev last week, and how many week-over-week change was happened in your deployments, or are you meeting CI/CD OKRs for that month? So these are all questions we have gathered over the last year and a half from firm-wide. So this forms our training data. As a lot of people have mentioned, you have to customize models, and the training data plays a very effective role in how your models are performing. So we went back to our knowledge base, articles across firm to build our own training data set. So just giving you a sneak peek of our conversational system. These are some of the screenshots. Just due to some compliance reasons, I'm not able to share beyond this, but say the query is entered and they hit the submit button and they retrieve the answer. So it could be just plain text or a CSV or a table or a graph. The intent of the question is sent back to the database query to get the relevant answers. So just to wrap it up, I'll pass it back to Bishwa.
Thanks, Mani. So you can see, I mean, we are on this journey for a while now, and there's a long way to go. And these are all the things which we are going to do on the system. Right now, it's in the testing phase. We are trying it out with the internal team and helping just the users within the team. But we want to take it out to the people outside the team and to the business unit and eventually to the entire firm. So with this, I think what we can do is we're trying to get to that goal of developers' productivity increase by 10x by answering one question at a time. Thank you.